Challenge B, this is logic, lesson 24, which is techniques for constructing truth trees. And it's really nothing new. It's just learning how to construct truth trees in a more efficient way and an easier way. So we'll go ahead and go through the lesson by doing an example here. And I have number 2 from the exercise. And what do you see? Well, we see 3 sets or 3 propositions, which is D, if and only if E then F, not D and E, D, if and only if F. So the first thing we need to do is write down our set members. So that's an easy part. We have line 1, and I'm going to write it in the middle here so that I have plenty of room to work. D, if and only if E then F. And then line 2, set member. Line 2 is not D and E, set member. Line 3 is D, if and only if F, set member. Okay, so the first thing that we want to look for is we want to do any non-branching members first. So we know biconditional branches, but here we have a conjunction, and a conjunction does not branch. So we're gonna decompose line 2 first. And a conjunction decomposes with just not D and E. So that was line 2, conjunction, decomposition. And it'd be the same for both lines. All right, now when we're finished decomposing a line, we want to put a check mark. So sometimes I forget to do that, but you put a check mark there so you know you're finished with that line. All right, next I'm going to go ahead and decompose line 1. And the reason that we would choose line 1 is because it's going to give us it's going to allow us to close a branch. All right, so first you want to do non-closing branches, non-branching members first, and then you want to look to see if you can close any branches. All right, and you'll see that when we decompose this, we're going to be able to close a branch. So line 6, all right, we're going to decompose line 1, biconditional decomposition. Oh, you know what? We need to give ourselves a little room for the branch. All right, I always forget about that. So here's the branch. So we'll write 6 a little bit lower. And this is line 1, biconditional decomposition. And the way that we decompose this is over here we'll have D and not D, and then we'll have if E then F, and over here not if E then F. So this is also line 1, biconditional decomposition. Okay, so right away you see that we have a not D and a D, which is a contradiction, and that is line 4 contradicts. Oh, actually, you know what? We have 2 lines here. We have line 6 and 7. So line 4 contradicts line 6. All right, so this branch is now closed, so we only need to work with this branch for now. Okay, now you'll see here we have a not if E then F, and a negated conditional doesn't branch. So let's go ahead and decompose this line first. Okay, and we get an E and then a not F. And that would be line 8 and line 9. And they both came from line 7 negated conditional decomposition. Line 7, negated conditional decomposition. Okay, so no contradictions. Let's put a check mark that we finished that, and I forgot to check mark line 1. Alright, so the only proposition left that we need to decompose is this line 3 here, and it is a biconditional which branches. Okay, and that would give us D and not D, and then F and not F. So that's line 10 and 11, and that was line 3, biconditional decomposition. So we write that down for both lines. Let's put a check mark because we're done, and now let's look and see if we find any contradictions. Here I see not F and F, which is a contradiction, so line 9 contradicts 11. And over here we have a not F, we have a not D, so I don't see any contradictions there, so this would be an open branch. So we had 2 closed branches and 1 open branch, and when we have an open branch we can recover the truth values. And I'm going to scooch the board over a little bit so I can show you how to do that. So we just list all of the members. We have a D, an E, and an F. Okay, so for this branch we have not D, so not D would be false, or D would be false. Over here we have E, so E is true, and F is negative, so F is false. So there's our recovered truth values, and that's how you do it. So just as a recap, here are the techniques. First of all, look for decomposed non-branching members first. Secondly, you want to look and see if you can close any branches, so do any of those members secondly. Next thing to know is if the truth tree yields its result, you can just stop. So for example, if we were to get an open branch up here, then we could just be done. We don't even need to finish the problem because we already have an open branch, and we see that that the proposition set is consistent. And then if none of those apply, then you want to decompose the more complex propositions first. Okay, have fun.